I'm going to show you how we can build a generic repository to handle all of our data access needs. We'll see this done in a simple ASP.NET application with Entity Framework and SQL Server. We'll use the Ardalis Specification package, which you can get on NuGet, to make our generic repository flexible and able to handle any kind of query for all entity types. Later, we'll handle DTO Mapping and Pagination within our repository so that this logic only needs to be written once. In the end, we'll have a robust data access layer which is decoupled and easily maintainable. This generic repository implementation is very similar to how it's done in the Nano Boilerplate, a premium project template with SaaS features like multi-tenancy, authentication, and clean architecture baked in. You can deploy unlimited projects customizable from the command line using the CLI tool, so head over to aspnano.com and check that out today. So let's get started. What I have here is a simple ASP.NET application. It is a web API, and what I've done so far is I've set up a DB context in a folder called infrastructure, and I've named it application DB context. In a folder called domain, I've created a base entity, and I'm using a generic here, TID, so that we can pass a type to use for our ID. Then our entities, like this one, product, will derive from base entity, and in product here, I've just got two properties. I have a name and then an integer for priority. You can download the finished version of this code on my GitHub and follow along that way. I've also got another folder here called common with this marker interface for our DTOs. We've got a response class, a pagination filter, which we'll see later, and a pagination response. And in our app settings, I have a default connection. In our dependencies, I have already included the usual suspects, the Entity Framework design, SQL Server, and tools. Okay, so let's create a generic repository. Let's start by creating an interface, and let's call it iRepository. Let's do the create method here. By the way, all of our methods are going to be asynchronous, so we're going to return tasks, and I will name them all async. Our signatures are going to look like this. We're going to use generics. We're always going to need to pass the entity type T, which will need to be an entity that derives from the base entity, and we'll need to pass the type for the ID. So let's create a class now called repository async that will implement the interface. And then let's set that up with our constructor where we inject the application DB context here. And here is how we can write our create method. This one's going to be pretty simple. We're going to use set and pass the type with add async and the entity. Upon success, we will return the entity. Let's do update now. Update will also be pretty simple. So we'll add our signature here, and this is the implementation of that method. We'll throw an exception if we find that nothing has been updated. Otherwise, we'll find the entity in the database, and if it's not null, we'll set the old values to the new values. Next, let's do the delete method, or we can call it remove. Remove by ID, and here's what that signature is going to look like. And here's our implementation. Again, pretty simple. We just find the entity, and if it's not null, then we remove that entity. None of our methods here actually save any of the changes. That is handled by a separate method, which we'll create now. So here's that signature in our interface. We're going to return a task with the number of records changed, and our method here is simply going to call save changes async and return the number. The thing about create, update, and delete is that usually there's not any kind of custom query that we pass to these three methods. The complications arise when we're getting data, when we're getting a single item, a single entity, or when we're getting a list. That's when we want to pass different criteria to our methods. Without the specification pattern, we wouldn't be able to customize the product queries more than we could the supplier queries or what have you. And so that's when complications arise, and that's why we need specification. So let's do this git list async, and we'll write our signature like this. The specification here represents a query that we could pass to this to only return products by a certain supplier, or to order the results in a certain way, or to also eager load categories or something like that. In order to do this though, we need a third-party package called Ardalis Specification. Specification Pattern is not necessarily dependent on a third-party package. We could write our own specification, classes, and evaluators, but it gets complicated quickly. Here, for example, is an older version of the Nano Boilerplate where we did write our own specification classes. We don't want to depend on Entity Framework or any specific ORM to build queries. We just want to be able to pass Lambda expressions so that we're not tied to Entity Framework or any specific ORM. To do that though is quite complicated because you have to account for all of these different methods like includes, order by descending, then include, and it just gets messy. To get this working on our own, we had the specification classes, these helper methods, and then we had the specification evaluator itself, and it became unwieldy. Luckily though, someone out there created a package to do this, and it does it very well. So that's what we're going to use. It's called Ardalis Specification. So right click your project and go to Manage NuGet Package and search for Ardalis Specification. We're going to need two. We're going to need to install this one, the Ardalis Specification package, and then we'll also install the Entity Framework Core package. And now here we can use Ardalis Specification, and this is our git list async signature. The actual method is going to look like this. We can pass that optional specification, and if we do, we're going to evaluate that with this specification evaluator, which is also from the Ardalis specification package. This will take that generic specification and turn it into an entity framework query. Then we'll return a list of whatever entity type we're working with. I'm going to create a new folder called services. I'm going to create an interface like this. Let's create another folder within this for our DTOs. Let's create a product DTO. Let's mark this as a DTO by inheriting from iDTO. Our DTO will look just like our entity with an ID, a name, and priority field. I'm going to make another one for create product request, and this one's going to have name and priority. And I'm going to do the same thing for update product request. In a more complex example, create product request and update product request would potentially be different. Maybe one of them has a parent entity, a parent ID that would not change when you're updating it, but only when you create it. That's typically the case, but in our simple example, they're just going to be the same. So let's import that namespace here using services DTOs so that our create and update product signatures are complete. I'm going to accept one criteria for when we get products, and that is for a keyword, which will search for a name. And next, let's create a class. Our product service will implement the iProductService interface. It will contain a constructor where we inject the repository, and we can implement our interface just to get things started here. Now, of course, we need to add async in front of each of our methods since we're dealing with asynchronous code. And let's do the create method first. So our create product async method is going to use that create product request DTO. Later, we're going to implement AutoMapper to take care of this for us, but for here, I'm just going to manually map that request. And here's where we're actually saving that product to the database wrapped in a try catch. And this line right here, line 28, this is where we're using our repository to create the new entity. And here, we're also using another method, the save changes async method from our repository, to persist those changes. So this is the key thing about a generic repository, is that this create method is going to work for all of our entity types. Since our generic repository is using delegates here, T being the entity and TID being the base entity, the ID type, whether that be a GUID or an integer, we just pass those two things, and this create method will work for every entity that we ever have, which is pretty useful. We can do the same type of thing here with our update product. Again, we'll use AutoMapper eventually here, but for now, we're just gonna manually map this request to an updated product, and we'll call the update async, passing the entity type and the GUID along with the entity, and then save the changes and return our response. Our delete product async method also gonna be pretty simple here. We're gonna call remove by ID async and save the changes, returning the ID. Now here for get products, remember that specification is optional, so we don't need to pass it. If we write our code like this, it's just going to return a full list without any search criteria. What we could do though is we could search for products by the keyword, and maybe we could also put some default ordering. That's what we can use specification to do. So let's go over here to our services folder and let's create a new folder called specifications. And let's create a new specification class. So I'm going to add a class, and I'm going to call this specification product search list. Our class is going to inherit from specification, and that's going to receive an entity type of the type that we're dealing with, in this case product. This specification class is from Ardalis. Now the way that we use the specification is we call the constructor like this, and we pass in any parameters. In this case, I'm just going to pass in this optional keyword, and using this query object, this is where we can start to construct a query that will later be evaluated by specification. So if I check all the different types of things I can do with query, there's quite a bit. I can do includes, I can do order by, I can do where, I can do a lot of them. I'm going to also do this default order by descending. We're going to sort our products by priority. So now back in our service method, I'll create this specification object and I'll pass it the keyword. And then I'll take this specification and pass it here to our getList async. Now when this method runs, we're going to have a specification here. And this is the code that will trigger. Our specification evaluator will build a query from this specification class, and it'll return a list of products that match that keyword, and they'll be ordered by priority. Let's go back up here to our create product async, and let's make this method better. Let's create another specification. Let's call this one product match name. Once again, we'll inherit from specification from the Ardalis package, and we'll pass it the product entity type. We'll take in a string for the name, and if we have something for that parameter, we will look for an entity that matches the name. So here we can check to see if the product exists or not using that specification, and if it does, then we can return a fail message. This way we prevent people from creating products with the same name. Actually, I can see that we don't have this method in our repository. Let's just go ahead and create that. Let's add this new method, exists. We'll accept an optional specification, and we're going to return a true or false. The implementation of this method will look like this. Very similar to our get list, except here, instead of returning a list, we're going to return a true or false using the any async method. The nice thing about specification is that we can reuse this query logic as many times as we want. And we know quickly what they're doing because we can give these classes descriptive names. When your application grows to be huge and your query logic gets to be really complex, that can be useful. Also notice that whenever we inject our repository into one of our application classes, we're injecting this one class. We're not injecting application DB context. And so in the event that you ever did change entity framework for something else like Dapper or whatever, you're only going to have to update this one repository class. You're not going to have to make changes across your 20 or 200 application services. And another benefit is that if you were using something like clean architecture and you had this repository existing in a class library for infrastructure, the ORM dependency would only exist here in infrastructure. Your application services don't have to know anything about what data access technology you're using. Using clean architecture is a good way to build scalable apps, and that's how you'll find things set up in the Nano Boilerplate, which is a premium template you can use to build SaaS and MVP projects in record time. It's way simpler to use than ABP. It's well documented on our website, so head over to aspnano.com to check it out and support our channel. Now we've got our repository starting to take shape. One thing that we could take advantage of, we've got this data access class. We could go ahead and take care of pagination here. Let's go ahead and create a new method in our interface. Let's call it getPaginatedResultsAsync. We'll return a paginated response with the entity, and for our parameters, we're going to accept an integer for the page number, the page size, and specification. This is a fairly generic way to set up pagination, but it also happens to be the way that TanStack table expects things to be. TanStack table is, I think, the best front-end library for tables. One of the best parts about it is that it is framework agnostic, so it will work the same whether you're using React or Vue or Svelte or whatever. There is a version of it for each framework, and that's what we use in the Nano Boilerplate. Also, the Nano Boilerplate comes with React and Vue. It's also headless, meaning that you can style it the way you want. This paginated response class is coming from here in our common folder, paginated response. It has a couple of calculated properties here. It takes in a few parameters, and so here's what the implementation of that method looks like. Same signature, we take in the page number and the page size, as well as our optional specification. We'll construct a query with this specification evaluator if the specification is passed in, and then we'll build a list of paginated results and return that as a paginated response. So let's go see now how that looks when we use it in the product service. Let's create another folder. Let's call it filters, and let's create a class. Product table filter will inherit from pagination filter. Pagination filter is going to take a page number and a page size. This sorting criteria allows us to dynamically click on columns in the table and send dynamic sorting criteria. That's outside of the scope of this tutorial, but you'll find all of that set up in the Nano Boilerplate. Let's import this namespace, and we can use our repository's getPaginatedResults method here. We just pass product and good, as well as the page number and the page size from our product table filter. This will return a paginated list without any search criteria. In our product table filter, we added one extra field though, keyword. So if we wanted to allow people to search by keyword, what we could do is we could reuse our product search list specification and just pass that in. Whenever I create application services in any of my applications, they typically look like this. I have an interface, I have the class, and then I have these three folders. Wouldn't it be nice if we could scaffold all of this easily? If you have the Nano Boilerplate, this is one of the things you can do. This can be a huge time saver. Another thing we can do here in our data access layer, in our generic repository, is we can handle all of our DTO mapping. We can provide alternate methods for each one of these entity methods that we have here, where instead we return mapped data. Since that would be highly useful and save us a lot of repetitive code, let's do that. Let's go here and manage NuGet packages, search for AutoMapper, and install this one. Now for the video, I'm just going to do this for one of the methods, but you can do it for the rest of them, or just download the sample code where all this is already set up. So on getListAsync, I'm going to provide another method, an overload method, which is named the same, it just has a slightly different signature. instead of returning an entity, we're going to return a DTO. And here we specify that tDTO is of type iDTO. So when we created DTOs, that's why we marked them with this interface. And in the method call here, we're going to pass 3 types instead of 2. We're going to pass the entity, the DTO type, and then the ID type. Now back here in the repository, I'm going to add the code for that. Pretty much the same as our regular Git list, except this time we're going to use this project2 method, and we're going to return DTOs instead of entities. Yes, of course we need to inject mapper. So in our constructor, we need to bring in AutoMapper using this iMapper interface. And in our project2 call, we need to pass mapper configuration provider. AutoMapper needs to know how we map our entities with our DTOs. So for that, we need to create a mapping configuration. So I'm just going to add that class to our infrastructure. I'm going to call the class Mapping Profiles. Mapping Profiles is going to inherit from Profile, which is a class provided by AutoMapper. Within the constructor, this is how we can set up our mapping. We'll also need to include AutoMapper here in our registrations. So let's add this line. Builder.services add AutoMapper type of mapping profiles. We also forgot to register our repository class itself. So add this line here, builder.services add scoped iRepository and repository the concrete class. Let's also add our product service. So we're going to add that as transient with the interface iProduct service and the class product service. Our application here with repository is nearly complete. The only thing we need to add now is a controller so that we can actually hit these services and interact with our application from the outside. Oh, by the way, one other thing you can create on the fly with the Nano Boilerplate is all of this code in controllers. So now my application is running here. So I'm going to go over here to Postman. I'm going to test out my create product endpoint. So I'm going to send name first, priority 1. I think I already have a product in there for second. Let's go over here to get products. And there we go. I can copy this ID for the second one and I'll paste it in here. And let's call it fourth. Okay, looks like it's been updated. I can get the list again, and now that's updated. We can delete a product as well. I'll recreate another product so that we can test out our pagination, and that is working also. So there you have it, folks. That is how you can create a generic repository. It's how you can decouple your application. You can use generics with specification to create one class that will take care of all your data access needs. It'll remain flexible enough so that you can handle any kind of query from any kind of entity. And we're also taking care of DTO mapping and pagination all in one place. So I hope you found that interesting. I hope that helps you with your projects. Again, the code is on my GitHub, so go ahead and download that, and then you can follow along with this a lot easier. You can use it in your own projects. Good luck, and see you next time.